Black holes. Even the name sounds ominous, doesn't it? These cosmic enigmas have fascinated scientists and stargazers alike for generations. These mysterious objects in space have captured our imaginations for decades. What are they exactly? How do they form, and what secrets do they hold? What would happen if you fell into one? Buckle up, space cadets. We're about to embark on a journey that will stretch the limits of your imagination. We're about to take a thrilling ride into the heart of a black hole. Imagine the adventure of traveling to the most extreme environment in the universe. Be prepared to have your mind blown wide open. The journey into a black hole is not just a physical one, but a mental and philosophical exploration as well. Imagine a place where gravity is so strong, not even light can escape. This is the ultimate trap, a point of no return. That's a black hole in a nutshell. But there's so much more to uncover about these cosmic giants. It's a region in space-time where matter has been squeezed into an infinitely small point. This point is known as the singularity, where the laws of physics as we know them cease to apply. This creates an incredibly powerful gravitational pull. The gravitational forces near a black hole are so intense that they warp the very fabric of space and time. It's like a cosmic vacuum cleaner on overdrive. Anything that comes too close is inexorably drawn in, never to escape. But don't worry too much. Despite their fearsome reputation, black holes are not out to get us. Black holes aren't lurking around every corner of the cosmos, waiting to gobble us up. They are actually quite rare and far away from us. They're actually quite far away. The vastness of space means that black holes are scattered sparsely across the universe. The nearest known black hole is still thousands of light years from Earth. This distance is so immense that it's hard to even comprehend. That's a very, very long distance. To put it in perspective, a light year is about 5.88 trillion miles. So thousands of light years is an almost unfathomable distance. So relax and enjoy the ride as we delve deeper into the mysteries of these fascinating objects. There's so much more to learn and discover. We're about to explore some mind-bending concepts. From the event horizon to the singularity, each aspect of a black hole challenges our understanding of the universe. Get ready to ponder the fabric of reality itself. The study of black holes not only helps us understand these mysterious objects, but also the fundamental nature of space, time, and gravity. Black holes are some of the most extreme and fascinating objects in the universe. They captivate our imagination and challenge our understanding of physics. They are formed when massive stars collapse at the end of their lives. This process is known as a supernova, a spectacular explosion that can outshine entire galaxies for a short period. Imagine a star much larger than our sun, running out of fuel and imploding in on itself. The core collapses under its own gravity, and the outer layers are blasted into space. That's the kind of cosmic drama that gives birth to a black hole. The core becomes so dense that not even light can escape its gravitational pull. These stellar remnants are so dense that their gravity warps the fabric of space-time. This warping effect is a key feature of black holes. Think of it like placing a bowling ball on a trampoline. The ball creates a dip in the fabric, right? This is a simple analogy to help visualize how gravity works. Similarly, a black hole creates a deep gravitational well in space-time. The deeper the well, the stronger the gravitational pull. The more massive the object, the deeper the well. Black holes, being incredibly massive, create the deepest wells of all. But here's the thing, black holes aren't actually holes in the traditional sense. They are regions of space where gravity is so strong that nothing can escape. They don't have a physical surface like a planet or a star. Instead, they have an invisible boundary called the event horizon. The event horizon is the point of no return. Once something crosses this boundary, it is inevitably pulled into the black hole. This is the point of no return. Beyond this point, the gravitational pull is so strong that escape is impossible. Once something crosses the event horizon, there's no coming back. It will be drawn inexorably towards the singularity at the center. Not even light, the fastest thing in the universe, can escape the gravitational clutches of a black hole. This is why black holes appear black. No light can get out. It's like trying to swim upstream against a current that's moving faster than you can possibly paddle. The force is simply too strong to overcome. You're going to be swept along for the ride. The immense gravitational forces will stretch and compress objects in a process known as spaghettification. But what happens to objects that fall into a black hole? They are stretched into long, thin shapes as they approach the event horizon. What would it be like to take a one-way trip to the edge of space-time? Let's find out. As you get closer, time itself begins to slow down relative to an outside observer. This phenomenon is known as time dilation. Near a black hole, time can slow down to a crawl, making seconds feel like hours. At the very center of a black hole lies the singularity, a point of infinite density where the laws of physics as we know them break down. Scientists are still trying to understand what happens at the singularity. It remains one of the greatest mysteries in astrophysics. With advancements in technology, we are getting closer to unlocking the secrets of these enigmatic objects. Observatories and telescopes around the world are constantly gathering data. In 2019, the Event Horizon Telescope captured the first-ever image of a black hole, providing a glimpse into the heart of these cosmic giants. This groundbreaking achievement has opened up new avenues for research and has deepened our understanding of the universe. Black holes are not just isolated phenomena, they are found in the centers of most galaxies, including our own Milky Way. At the heart of the Milky Way lies Sagittarius A*, a supermassive black hole with a mass millions of times that of our Sun. Stars orbiting this black hole provide crucial clues about its properties and the dynamics of our galaxy. Black holes are truly one of the most intriguing and mysterious objects in the universe. They challenge our understanding and push the boundaries of science. As we continue to explore the cosmos, black holes will undoubtedly remain a focal point of fascination and discovery. Join us as we delve deeper into the mysteries of black holes and uncover the secrets of the universe. The journey has just begun. Imagine approaching a black hole. It's one of the most mysterious and fascinating objects in the universe, a place where the laws of physics as we know them break down. As you get closer, the pull of gravity gets stronger and stronger. This gravitational force is so intense that it warps space and time around it. You'd start to feel a bit stretched, like a cosmic rubber band being pulled taut. This phenomenon is known as spaghettification, where the difference in gravitational pull between your head and feet becomes so extreme that it elongates your body. Don't worry, it's not painful, yet. At this point you're still outside the event horizon, the boundary of the black hole. Eventually you reach the event horizon. This is the point of no return, the boundary beyond which nothing, not even light, can escape. The event horizon is like a veil, hiding the secrets of the black hole's interior. Light bends and twists around it, creating a mesmerizing, almost hypnotic effect. Think of it as a cosmic trapdoor. Once you fall through, there's no coming back up. It's a one-way ticket to the unknown. Once you cross the event horizon, you are irrevocably drawn into the black hole's depths. The gravitational pull is so strong that escape is impossible. Now here's where things get really weird. The laws of physics as we know them start to behave in strange and unpredictable ways. As you cross the event horizon, time itself starts to behave strangely. Due to the intense gravitational field, time dilation occurs. From your perspective, time would seem to slow down to a crawl. Seconds stretch into minutes, minutes into hours. It's as if the universe itself is hitting the pause button. You'd witness the entire future of the universe unfold before your very eyes. Stars being born, galaxies colliding, the ultimate fate of the cosmos. Pretty trippy, right? Meanwhile, to someone watching from a safe distance, you'd appear to freeze in time at the edge of the black hole. Your movements would slow down until you seemed to be suspended in space. Your image would redshift, becoming fainter and fainter until it eventually fades from view. This is because the light you emit is stretched to longer wavelengths, making you appear redder and dimmer. It's like watching a movie where the main character gets stuck in slow motion. Every action, every movement is drawn out in an almost surreal manner. Crossing the event horizon is a one-way trip into the unknown. What lies beyond is a mystery that has puzzled scientists and astronomers for decades. We can only speculate about what lies beyond this point. Some theories suggest a singularity, a point of infinite density where the laws of physics cease to exist. Others propose the existence of a wormhole, a gateway to another part of the universe or even another universe entirely. But one thing's for sure, it would be a journey unlike anything else in the universe. The experience of crossing the event horizon and venturing into the heart of a black hole would be the ultimate cosmic adventure, a voyage into the deepest, darkest mysteries of the cosmos. Section 4. Spaghettification. Don't worry, be long. So you've crossed the event horizon and entered the black hole. What happens next? Well, get ready for a wild ride. As you fall deeper into the black hole, the gravitational pull on your feet becomes much stronger than the pull on your head. This difference in gravity, called a tidal force, stretches you out like a strand of spaghetti. Don't worry, it's a gradual process. You won't suddenly snap like a twig, but over time you'd be stretched thinner and thinner. You'd literally be turned into a long, thin noodle. This process, known as spaghettification, is a real thing. It happens because of the extreme tidal forces near a black hole. The closer you get to the center, the more extreme the spaghettification becomes. But hey, look on the bright side. You'd be the longest, thinnest person in the universe. That's gotta count for something, right? Just try not to think about how you'd look in a bathing suit after this. Section 5. Time twists. Relativity at its finest. Black holes are like cosmic playgrounds for Einstein's theory of general relativity. This theory tells us that gravity is not a force but rather a curvature of space-time caused by massive objects. One of the most mind-bending consequences of general relativity is time dilation. This means that time slows down in stronger gravitational fields. So near a black hole, where gravity is incredibly strong, time would pass much slower than it does on Earth. Imagine you had a twin sibling who stayed on Earth while you took a trip to a black hole. You spend just a few hours near the black hole. But when you return to Earth, you find that years, even decades, have passed for your twin. That's because time slowed down for you relative to your twin on Earth. You've essentially traveled into the future. It's like something out of a science fiction movie, but it's a real consequence of Einstein's theory. Section 6. The Singularity, where physics takes a hike. As you continue your journey towards the heart of the black hole, you'll eventually reach a point called the singularity. This is the point of infinite density where all the matter in the black hole is concentrated. At the singularity, our current understanding of physics breaks down. We don't have a complete theory of quantum gravity, which is needed to describe the conditions at such extreme densities and pressures. Think of it like this. Our current laws of physics are like a map that can guide us through most of the universe. But at the singularity, it's like we've reached the edge of the map. We need a new map, a new set of rules, to understand what's going on there. Some theories suggest that at the singularity, all the information about the objects that have fallen into the black hole is preserved. Others propose that this information is lost forever. It's one of the biggest mysteries in modern physics.